Well, hello again. In my last video, I kind of didn't like how the property part went, so I'd like to redo that. So that is what this portion of, or this video is all about. The property section, I'm just going to kind of cut out, and I'd like to kind of talk about it in terms of, or in a little different way that might make a little bit more sense. So the first thing I'd like to do is I would like to share with you kind of my screen. And I'm going to present to you kind of a table. So when you take a look at this table, you might want to pop or stop your video and make sure that you kind of copy down the table. The table has 2 columns and 8 rows. So if you want to go ahead and make that now, you can. So take a moment, stop your video, and make and set up your table for this portion of your notes. Now, please remember up in the upper right-hand corner, please put the date so you have an idea. Your notes are then in order. Also, just to keep you somewhat organized. So let's kind of get started. The first one is, how do you find the limit of something that is a constant? So when we're talking about that, we're trying to find the limit as x approaches c of some sort of constant. And that constant, we're just going to call b. So that could be any constant. It could be 2, it could be 4, it could be -7. But you're trying to find the limit of a function that is a constant. So what is that exactly? Well, when I think about a constant, you need to remember a couple of things. Constants are horizontal lines, okay? So wherever the constant is, it's going to be a horizontal line that goes through whatever that value is, okay? So what is that going to be when a function is a constant? Well, I want you to think about this. If you go to any c and you come from the left, or you go from the right, you notice that your answer is always going to be b. So when you find the limit of a constant, it always is the constant. Okay? So what's it going to look like if you find the limit of the most simplest function that we have? So let's say I gave you the limit as x approaches any c of the most basic function, and that most basic function is x. What is that going to look like? Well, for me, I like to think of this one graphically as well. Remember, the function y equals x is a slanted line that goes through 0, but remember, it's simple. For every x, it's equal to y. So if you pick 1, the y value is also 1. So here's how this works. If you do direct substitution and you substitute this in, so here's the x value c, we get close to that. What is the y value it's heading towards? The y value is c. So the limit of the most basic function, x, when you approach any c, the limit is c. So what do you do, though, if the functions aren't as simple? What if we're going to find the limit of something that appears as we approach c of, 2 functions that might be added together? So what if we have f of x plus or minus g of x? Okay? What if we have those as our 2 functions? Okay? And for example, like one of them could be, x squared, and one of them could be x plus 1. And these are being added and subtracted together. Okay? What if we had that type of function? What do you do? Okay. Well, the easiest thing to do is treat them as separate pieces and substitute this in. So we're going to substitute c in for every x in the function of f of x, and we're going to substitute c into every x into g of x. So what is our answer going to be? I'm not going to make a graph for this one, but I am going to say our final thing would be we would have f of c, whatever that y value is, plus or minus g of c. Okay, so we just take them in as two separate chunks. So, you know, if you were thinking about this, it would be c squared, if we use the example underneath, plus or minus c plus 1. Okay, and we just substitute that value in. When we talk about properties, we always talk about them in terms of any number. So we use variables to represent those things. Okay? So what if two things are being multiplied? What if we have the limit as x approaches c, but our two functions are actually being multiplied together? So we have f of x times g of x. Okay? And those two things are being multiplied together. What do you do? Okay? Well, you do the same thing that you did with addition. We just go with direct substitution, and we substitute them in to the expression. Okay? So, for example, with this one, all you would have as an answer is whatever f of x was, you would plug in c. So you'd find the y value for that times the y value for g of c. Okay? Substitute it in. Now, in the upcoming days, we're going to talk about what you do and how you figure that out. But this is what the properties allow us to do. So simply remember, up to this point, that whatever you do, you're just really substituting c in until you get places where it doesn't exist. So the same thing holds true for division. What if I gave you the limit as x approaches any c of the function f of x? So there's some function on the top of the fraction, and then there's some other function on the bottom of the fraction. What do? Well, you substitute whatever that value is into the numerator, and you substitute that value in for whatever is in the denominator. So it's going to be f of c over g of c. Now, just remember one thing, though. If you substitute that value in for g of c, and this equals 0, you have to do some other stuff to do the calculation. So if this equals 0, the answer is going to be does not exist, or we have to use other methods. Okay? And in our next lesson, we're going to talk about those other methods that you can use. Okay? So just keep that in mind when you're working with division. Excuse me. Now, what if you have something where you have a function and it has an exponent? Well, what if I give you the limit as x approaches some value c, and you have this function, let's just call it f of x, because we don't know what it is, but it's to some sort of exponent. Let's make an exponent that's a fraction, like r over s. So you could have 2 over 3, or you could have 4 over 2, or something like that. What do you do with that? Well, as I showed you before, you take your c and you substitute it in for every x of that function. So what is your answer going to be? Well, it's going to be f of c to whatever the exponent is. And as long as it exists, okay, this is what your final answer is going to be. So in the beginning, most of these things are going to exist. Then we'll start talking about what we do when things don't exist. How do you then calculate the value, or what is the limit going to be? Now, the most complicated of them all is what you do for the limit of a composite function. Okay? Now, if you remember from pre-calc, okay, where first of all, of course, the limit's going to approach c. But if you remember, A composite function is a function embedded in another one. So I always use this word. It's embedded into another function. So we have g of x inside of the function f of x. Okay? So what do you do here? This one has more of a rule that you kind of are going to have to memorize. Okay? So the first thing you're going to have to do is we're not going to do anything with the f of x part. What I need you to do is I need you to find the limit as x approaches c of the inside function. So you need to find the limit as x approaches c of the g of x function, that inside part. So what do you do with the inside part? Well, remember, we just do direct substitution right now. And as long as that number exists, you can say that you know what the limit is. So here's what we have. If we do direct substitution, we now figure out that g of x is some y value, g of c. Okay? Now, you do not take the limit of the f of x function. You just now plug this value into f of x and figure out what it is. Okay? And that is how you figure out the limit of a composite function. I will show you many examples of these when we get to class and we talk about what that means and how that works. Okay? So these are the properties of limits. I hope this makes sense. I hope when you start to see some examples that they make more sense. And please come to class with lots of questions if you do have them. So I'm just going to stop presenting so you can see my face at the very end. And I do hope that these notes, you have them down. So when I see you next on Monday, we can have a discussion about how these properties work. The lesson after this is going to be on the